Number 1 says the water level in feet at a certain beach is modeled by this function where t is the number of hours since the level was measured. What is the amplitude of the function and what does it mean in context? So the amplitude is here, this 2 times the function or 2 times the sign. And what it means is that's how high the water rises and falls. So it means the water rises and falls 2 feet from like normal sea level. So it'll go above 2 feet above and below the like where they started measuring it at. And then the period in this one is 2 pi over 24 is the B value. So this means every 1 rotation, you'll have 1 rotation in 24 hours. So the period is 24. And it means that you're going to get 1 high and 1 low tide every 24 hours. So if we were going to sketch this, when they start measuring it, since it's a sine function, it'll be at 0. And then it will go to a high and then back to a low and back to normal in 24 hours. So halfway between 0 and 12, it'll be at a high tide. Then it'll be back to normal and it'll go down to a low tide halfway between, and it'll keep up this pattern. So halfway high, back to normal, low, back to normal, high, back to normal, low, and then back to normal. So then you're getting in these branches. So obviously you can probably sketch better than me on this system, but that's kind of the idea there, is it would do that. Number 2, the amount of moon visible D days after November 30th is modeled by this equation. Select all statements that are true. So the model predicts a full moon on December 6th. So December 6th would mean that D equals 6. And so if we put a 6 in here, that's going to be 6 minus 6, which is 0. So that's going to zero out this whole thing right here. So we're going to get 0. So this is going to be 0.5 times cosine of 0 plus 0.5. And cosine of 0, so cosine is here at 0, cosine's the x value, so that means that's going to be 1. So 1 times 0.5 is 0.5. So when we do 0.5 plus 0.5, we get 1, which is 100% of the moon showing. So that would be a full moon. The model predicts that there will be 2 full moons in December. This is false because there's going to be 1. So in one cycle every 30 days. So this means there's going to be 1 full moon every 30 days. And so if the first full moon is starting on December 6th, if we add 30 days to that, that's not going to be in December. That's going to push into January. So this would be false. The model predicts that none of the moon will be visible on December 21st. So again, that's D equals 21. So if we go back into here, we'll have 21 minus 6, which is 15. So 15 times 2 pi. So we have 2 pi times 15 divided by 30. So that's going to be 30 divided by 30. So we're doing cosine of pi. So we have 0.5 times cosine of pi plus 0.5. Well, cosine of pi is -1. So then 0.5 times -1 is going to be -0.5. And then plus 0.5 is going to give us 0. So that is going to be true that none of the moon is visible. The model predicts that more than half of the moon will be visible on December 13th. So this is D equals 13. So when we plug it in here and we do 13 minus 6, that's 7. So we have 2 pi times 7 over 30. So that's going to be cosine of 14 pi over 30. And 14 pi over 30, would be just before halfway to pi. So here's pi. So 14 over 30 would be just before that. And in the first quadrant, cosine is greater than 0. So if we're doing a 0.5 times a positive number, that's going to add on to this last 0.5. So we know that we're going to have this part is going to be positive, okay, plus 0.5. So that's going to be just over, or it's going to be more than half. If we're adding a positive number plus 0.5, that's going to be more than 0.5. It's going to make this go up. And then the model predicts there'll be a full moon every 30 days. Yes, we talked about that in part B. So we said every 30 days. So that one's true. Number 3, 1 month. The amount of moon visible after D days after the beginning of the month is modeled by this equation. So very similar to what we just did. Explain why the moon will be full when these two numbers are equal to each other. So when 2 pi d over 30 is equal to pi over 4. And that's because if you subtract two quantities that are the same, then they'll equal 0. So then we're going to end up doing cosine of 0. And cosine of 0 is equal to 1. So then we're going to be getting 0.5 plus 0.5. So that's going to give us 100% when we get 0 inside of here. Explain why none of the moon will be showing when 2 pi d over 30 equals 5 pi over 4. So if 2 pi d over 30 equals 5 pi over 4, I can just substitute that in here. So then we'd be looking at, so I just want to show you plugging this in. So then we'd be looking at 5 pi over 4 minus pi over 4, right? So then we'd be getting this cosine portion to be 4 pi over 4, which is just pi. And the cosine of pi is its minimum, right? It's at -1. So then this whole thing is going to equal -1, which is this whole part right here. So we'd be doing 0.5 times -1 and then plus 0.5. So this is -0.5 plus 0.5. That's going to be 0, okay, or none of the moon, because you're going to get cosine at its minimum. And then sketch the graph of this. So I would just figure out kind of how many days, because we have a little bit of a phase shift here, because this is where cosine is at its max. So I would solve for the number of days here to figure out where cosine's at its max. So we can just multiply by 30 and divide by that, bring that 2 pi down. So we'll have d equals 30 pi over 8 pi. We do 30 times pi and 2 pi times 4. So then those pi's will cancel out, and 30 divided by 8 equals 3.75. So at 3.75, this cosine is going to be at its maximum, which is going to be 0.5 in this case, since the amplitude is at 0.5. So we're going to oscillate between 0.5 and -0.5. And then your period here is 30 days. So then let's take and divide that by 4 to figure out how often it's going to be going to a like max, a middle, or a min. So every 7.5 days. So at 3.75, a fourth of the way past that will be like 11.25. It'll be back at a minimum. And then add another 7.5. So at 18.75, it'll be at a minimum. And then another 7.5, which is like 26. It'll be back at 0. And oops, I guess 26 is a little bit further over than that, probably more like here. And then add another 7.5, and it'll be like 33.75 will be at a max. So then you get kind of this idea here. All right, so then that's kind of where it'll be. And then remember that we also were up 0.5. So this moved up 0.5 for your midline. So that's just going to take all of this stuff here. Let me just grab it, and it's going to move it up to 0.5. So it's going to move that midline up to 0.5. So it's going to be like that, so that you get your midline here right in the middle of it. So I just did it over the 0 and then moved it up to that 0.5. Number 4, the center of a clock is 0, 0 in a coordinate system, and the hour hand is 8 inches long. It's 10:30 p.m. Which of the following are true of the end of the hour hand? Select all that apply. So, you know, we've got a clock here. Let me just draw it on with a couple markings here, since we're going to want to be thinking about it in sort of the unit circle. So you've got 9 o'clock here, and you've got 12 o'clock here. So we have 10 and 11. And now we're going to be halfway between, because we're at 10:30, right? And so on the unit circle, that would be halfway between. So these are going to be your pi over 4 coordinates. And so we're at a negative x and a positive y. So when we look here, this one has a positive x, negative y. So that's certainly false. And this one's negative, negative. So this one would be down here. This one would have been positive, negative over here. So A is good. And then where it's coming from is this ordered pair is really negative 1.41 and 1.41 on your unit circle. And then since the hand is 8 inches long, we have to actually multiply 8 into both of those. And that's where that 5.7 is coming from. And then another way to write that would be 8 times the cosine of 3 pi over 4, because this angle would be 1 pi over 4, 2 pi over 4, 3 pi over 4 to get right in that pi over 4 angle in the second quadrant. So we could do 8 times cosine of 3 over 4, and 8 times sine of 3 pi over 4 would also get us those numbers. E is wrong because sine is the y coordinate, cosine is the x coordinate. Number 5, label these points on the unit circle. So Q is the image of P after a negative pi over 6 rotation. So negative pi over 6 would be about there. R is the image after a negative pi over 2. So negative pi over 2 would be here. S is the image after a negative 4 pi over 3 rotation. So pi over 3, right? If we split this kind of half circle into 3 pieces, so we'd be at 1, 2, 3 pi over 3, 4 pi over 3 would be somewhere over here. And then negative 5 pi over 3. So again, 1 pi over 3, 2 pi over 3, 3, 4, 5 pi over 3 would be here. Number 6, the function h given by h of theta equals 15 plus 4 times sine of theta models the height in feet at the tip of a windmill blade, has rotated through an angle of theta. So what is the height of the windmill? And the height matches the midline. Okay, so the height is 15. And that's because the midline, you know, tells you where the center is. And then what is the length of the windmill blade? And that's equal to the amplitude. So that's this 4 times the function. So this is 4 feet. So both of these are feet because we're being measured in feet. And that's because this is how high / low this point moves. So how high and how low the point moves from the center. So then that point is going to move, you know, how far the blade is. So then it'll go up, over, down from the center. So then that's telling you how long the blade is. Number 7, the vertical position of a seat on a Ferris wheel is described by this function. Time is measured in seconds and output is measured in feet. So write an equation describing the vertical position of the Ferris wheel of the same size but spins twice as quickly. So the speed of this Ferris wheel says 2 pi over 30. So that means 2 pi is 1 rotation. So this is 1 rotation in 15 seconds. So in 30 seconds, and we want it to go 1 rotation in 15. So this is 1 rotation in 30 seconds. So if it's twice as quickly, we would want 1 rotation to happen in 15 seconds. So we'll just change that bottom number to 15. So let's use a different letter. So G of t is equal to 80 sine. So we're keeping it the same size. And then we just want to change this to 1 rotation in 15 seconds. And then plus 95. Now in this second part, it wants the same speed, but it wants it to be twice as large of a radius. So that's going to change this front number. So if we're looking at this one, we want to change the front number to 160 so that it's twice the size. And then we'll leave this inner part the same. So we'll do 1 rotation in 30 seconds like the original. Now, you got to be careful with this last number because plus 95 won't be good because this is not higher than the radius. So that means that this Ferris wheel is going to smash into the ground if it only starts 95 high and it needs to go up or down 160. So you need to just put a new number here. Okay, and it doesn't matter what number this is, but it has to be higher than 160. So you can pick 170, you could pick 178, 180, 200, but this number just has to be bigger than 160. Number 8, here's the initial position of a bike wheel before it starts to move. The vertical position in inches of P is given by this function. S is the number of seconds since the wheel began to move. Select all true statements. So the wheel makes 3 revolutions per second. So let's take a look at this. And so I would write this as 2 pi over something because we want to figure out how often it's going rotating in 2 pi. So in order for the 2 pi to turn to a 6, this bottom number needed to be 1/3. So 2 pi divided by 1/3 equals 6 pi. So this means 1 rotation in 1/3 of a second. So that means if we're looking at per second, that would mean we'd get 3 rotations or 3 revolutions is what they're saying. 3 revolutions equals 1 second. So 1/3 of a second for 1. So that means we're going to get 3 in 1 second. So A is good. The wheel makes 1 rotation in 3 seconds. No. 1 rotation in 1/3 of a second. All right, so then it says after 1 second, which is giving us 3 revolutions. Okay, so after 1/4 of a second, P will be in the position marked Q. So I would do, so if we're doing 1 second, then we're doing 1/4 of 3 revolutions, right? Since 3 revolutions per second. So this is really getting 3/4 of a revolution. So P is actually moving 3/4, and here's P, so 3/4 of a revolution. So here's 1/4, 2/4, 3/4 of a revolution does put us on Q. So this one would be true. Now, using that same idea for part D, it says 3/4 of a second or 3/4 of a revolution. Okay, so 3/4 of, well, of 3 revolutions, right? So 3/4 of 3 revolutions, since that's what happens in 1 second. So this is actually going to get 9/4 of the way around. Okay, so this is going to move P 9/4. So this is 1, 2, 3/4, 4/4, 5, 6, 7, 8, 9/4. So 2 1/4 rotations. And that is not putting P back on Q. Then E, the radius of the wheel is 10 inches. Remember, that equals the amplitude, and we can see the amplitude here is at 10, so E would be true.